So in-vehicle network attacks and countermeasure. Okay. So first let's look in-vehicle network. Yeah. So you see this is a image of a in vehicle, right, a car, and there are lots of controls, you can say, yeah, and these controls are connected by some network. Okay. So we will come to it how exactly they are connected. Yeah. So if you look this kind of contemporary vehicles or car, they have several features and these are basically powered by some electronic systems. Yeah. And these features help the drivers and the passengers in terms of convenience or something they want to do. Okay. So there is a lot of electronic systems. Okay. And these electronic systems are realized into something called electronic control units. Okay. So if you look at typical car, modern car, you will find like 100 or 200 electronic control units in which lots of tasks are happening during driving depending upon what exactly you are doing in the car. Okay. And these ECUs are connected by a network that is called control area network. Yeah. Or you might have heard CAN bus. Yeah. This is very popular in vehicle networks. Okay. And this is sort of the de facto standard for communication among electronic control units in the vehicles. Okay. So CAN is basically connecting all the electronic control units. Okay. Now let's look a bit more detail about this network. Okay. So this network connects to external systems through connected and autonomous vehicle technologies. Okay. So anything you want to do in the car, like you want to play maybe some song or something, there will be a controller for it. Okay. That will facilitate that process. Okay. But the problem with this CAN is it does not provide confidentiality, authentication or access control. So it has no kind of security proof mechanisms, and that is why it allows attackers to access the CAN bus and attackers can inject some packets. Yeah. So it's like they can throw something into some electronic control units and then whatever the car was supposed to perform, it will do something else. Okay. And with this kind of approach, attackers can target some essential functions, yeah, such as emergency braking. Yeah, you want to apply, but then that particular electronic control unit that is supporting the brake, maybe it's malfunctioned. Yeah, then basically brake will not be applied. Okay. It can be acceleration as well. Yeah, so like you are trying to accelerate your car, but the corresponding electronic control unit has been attacked, or like the real information in it has been changed because there is no proper authentication or confidentiality. Okay. And it could be steering control. Yeah, like you are going on a car, it's like a straight, but you have to turn, but if someone attacks, maybe you cannot turn the car and then you crash. Okay. So a lot of these things are possible. So now how the attack on the CAN bus can be done. Okay. Let's look a bit. So a potential attacker basically may exploit some external interfaces. Okay. Something called like OBD2 diagnostic port or some telematics unit or in-vehicle infotainment system. Okay. And they can launch some attack on a real car from there. So let's say this is a car, right, and there are a lot of electronic control units into it. So the CAN bus in the car can be connected with some external interface, and these can be the external interfaces. Okay. So with OBD2 port, an attacker basically can send some message into some electronic control unit that might be compromised, and this one, like I said, maybe it's a steering control or it's a brake or it's acceleration. So those things are not going to happen. Okay. So this is how the attack can be done. And what exactly it will lead to? It will be basically denial of service and malfunction and a lot of other things. Yeah. So basically not doing what exactly it should be doing. Now how the CAN bus frame looks, yeah, because you want to do the attack, which means you want to change something into the frame, yeah, which means these frames are going into different electronic control units, right. So you want to change the value. So the frame looks something like that. It has some bit for a start of frame, this CAN ID, this is something called like data length code, yeah, and this data payload and some checking, acknowledgement, and in the end of frame, okay. So here what exactly you can do, you can change the CAN ID and data payload to trigger an attack, okay, because there are a lot of CAN messages going from one controller to another. So for a particular CAN ID that might be going into some electronic control unit, there is some payload as well going with it, right, to do the braking or to do the acceleration. And if you can change that payload, then it will not do acceleration, it might do something else, okay. So this is how basically you can change the payload and CAN ID to do the attack. So this is a kind of sample data for Tesla Model 3, yeah, how exactly the data looks in Tesla Model 3. So you can see there are a lot of CAN IDs, and this is data length code, which means how many bytes are going to be used for the whole data, yeah. So you can see like data 0 to data 7, there are some data stored, okay. This is the sample data, yeah, there are like millions of CAN IDs flowing, yeah, because there are so many things happening in the car. So this is an example, but here this one is a real data for Tesla Model 3. So you can see like this is some index, like from the software we extract the data, this is the time, this is the CAN ID, and the data length code is not 8 always, yeah, which means how many this payload are there, okay. So if it's like 7, there will be 7 payloads, last one will be empty, okay. If there is 2, only 2 payloads, rest of them will be empty. So this is from Tesla Model 3, yeah. And now to do different things, there is different payload, yeah. If you can change whatever is car supposed to do, it will not do that. So now let's look at real attack, yeah. So this is changing the CAN ID and payload, trigger the lighting, yeah. So it's like car is standing, but for the CAN bus you can connect with some ODB port, and through the ODB port for a particular CAN ID you can change the payload and it will just trigger the lighting of the car, whereas you are not doing from the real control, okay. So let's look this video.
Here I'm showing to you how we can attack the car through the CAN bus.
So this is done by one of the master's student, yeah. So this is a
and here is the device we used to
inside Tesla Model 3, yeah.
From the car. And here it is the OBD port we used.
So in the car this is available, yeah. You can connect.
And this one is the cabin we used to connect it with between this device and the car. And we plug it in the OBD port. And here is the USB we used to connect between the laptop and this device. And here is the software we use to read the message from the canvas. And now we can see there are so many messages.
I pasted some of it, yeah, in the slide before.
Try to do some attacks. I can control many things, and now I show you I can change the light. And here is the message which can control the light from the canvas. And if I press the set button, the light will shiny. And let me show you. Yeah.
So you see, like for a particular CAN ID, you change the payload and then it turns on the light, yeah. So it's
And
kind
when I
of,
send it, when I stop it, and that's all.
so there is no proper way to find out what is exactly the payload for different controls. So this is like trial approach, yeah. We found for this is like the payload for the light to turn on by sending the through the CAN network, yeah, for particular CAN ID, because that ID is going into that electronic control unit that is connected with the light, yeah. So now imagine if you can find the payload that controls the steering, yeah, you can maybe freeze the steering, yeah, or you try to accelerate the car, but you pay, I mean, when you accelerate the car, the payload will change, right? But you may put some payload always constantly, and then it will not accelerate, it will not move, yeah. And the reason we could do this CAN is no authentication or something in the car, okay. So it's very easy. There is a port, you connect, and then you can do it, yeah. So with this one,
here I'm showing to you how we can attack the car through its camber.
So we have also performed attacks like opening the back trunk, yeah. So you're like standing, but you can open the boot just by changing the payload, and also turning indicator, yeah. You're not doing anything, like not the control, but rather just by this changing the payload, okay. I think a student is still trying to figure out what can be the payload, maybe to freeze the steering or something, yeah. It's very dangerous. So that is why you see this car, it's never moving when things are being done. And also there is a lock. It's like in a compound, yeah. If something goes wrong, maybe the payload you put, maybe it starts moving, right, or accelerates. So it's in a very closed compound. Anything crashes or something, it's not a problem, yeah. So the vehicles are really insecure, yeah. Imagine like someone getting that kind of access from internet, and then he can just try changing the payload, and lots of things are going wrong in your car, okay.
Imagine integrating AI with that.
Yeah. So yeah, so cars are very insecure, okay. And with more connectivity, nowadays cars are connected, right? I don't know if you know, like there are some cars like now connected with cloud. If you're driving, they ask like to do some updates over the cloud. Like you will be scared, like you're driving and some updates are happening. And when that update is happening, imagine some attacker getting access to that, yeah. Okay, so now because CAN is so sensitive, I think some automotive companies, like one in US, General Motors, they're coming with a different infrastructure for communicating that can be more secure, yeah. But there is again no authentication or confidentiality, yeah. That just kind of more secure it can be, okay. Yeah, I think they're trying something like compartmentalize it. So it's like one network for critical systems, one network for infotainment system, one for maybe driver assistant, something like that. So there is never a kind of only one bus, CAN bus, that is always talking. So just to have different kind of messages in different sections, yeah. Okay. Okay, I think this is the question now. How such attacks can be mitigated? So how we can stop these in the car? Can you think of some? Let me put that slide. Any ideas you can think how this changing the payload for a particular CAN ID can be avoided? So again, this is very active research, yeah. People who work in automotive systems, they do a lot. Encrypting, good idea, but like I said, in the CAN bus there is no authentication or encryption. Maybe it's because it's already very heavily loaded system, yeah. There are so many messages are flowing from one to another, yeah, when the car is running. Maybe there are like thousands of messages. So if you encrypt, these are longer messages, yeah. So it can basically impact the performance, yeah. I think one of the reason is car is like a critical system, yeah. Like I said, when you, there are some critical parts, yeah. Apply the brake, it should be applied immediately. You turn the steering, it should be done immediately, yeah. If you encrypt, it may take some time to respond. That's the reason, like, they don't want to do a lot of these things, yeah. Okay, so don't worry, next slide is about that. So let's go and check, but in another one, yeah. This one. All right. Okay, so to detect and mitigate CAN bus network attacks, we can have something called an intrusion detection system. Yeah, this is very popular again. Yeah, so you remember, this is how the attackers, with one of the external kind of interface, they can send the message. Yeah, so in one of the electronic control units, you can have some sort of monitoring. Yeah, what exactly is the payload coming? Yeah, so all the payload pass through it, and then it goes to the relevant control units. Yeah, so if you find out like this kind of payload has never been observed, you can do some alert. Yeah, so I mean, it's still not stopping, or that payload you may stop sending to the electronic control unit, it is going. Yeah, so lots of people have developed this kind of systems like intrusion detection system. So what it is going to do, basically it's just going to filter out malicious traffic or malicious payload, yeah, that attacker tries to send to the CAN system, okay, and generating the alert system, okay. So that's just high level overview. Now I wanted to kind of introduce some kind of methods that has been proposed in the literature already. So these are like the two intrusion detection system methods, yeah. So one is based on deep convolutional neural network. So again, you may feel like it's trying to find a pattern that has not been observed, yeah, or it's deviating too much from already existing patterns of the payload. So a CNN is used for that. That is in this paper, and there is another approach, kind of multi-layer perception approach, again CNN based, to kind of just detect and stop that, okay. So it's just basically you need some kind of intrusion detection system. Everything that comes in the car, in the CAN bus, has to be checked there, yeah, and if it is deviating too much from already seen workload, then you somehow stop it, okay. Yeah, but to my knowledge, in the real cars, there is nothing like that, yeah. So you can still attack. That is why we could attack this Tesla Model 3, yeah. So now a key message for modern cars. So now you can see modern cars have increasing features, right? So with increasing features, there will be trade-off between resource requirements. Yeah, they're like limited electronic control units. You want to do more in that. So the complexity is increasing. Yeah, and we want to extend the functionality as well. Yeah, so there is kind of extendability issues. And with all these, there is another issue called like certifiability. Yeah, so in a car, if any new component is put, it's not like the system we use. Yeah, there is always a certification. Yeah, upgrade something, it has to be certified, because it can kill someone. Yeah, so such kind of system need that kind of thing. So again, with all the increasing functionalities that we are getting in the car, engineers have to solve this kind of trade-off. Yeah, confidentiality, complexity, extendability. Okay, good. I think we will stop here. Yeah, in the afternoon we are going to look some defenses that is based on authentication. Yeah, authentication you know very well. Yeah, we always do it. So we are going to look like how that can be done, or even if you do some authentication, how that can be bypassed. Yeah, that's not sufficient. Attackers are clever enough to kind of bypass that, and then how we can stop that. Okay. Yeah, let's look in the last 1 hour in the afternoon. Okay, I think we have 1 hour. Yeah, 2 to 3. So we are changing the structure a little bit. Yeah, I said in the morning. Yeah, so lecture 7 was about design methodologies for sustainability, and then there was something about security. So I said we will cover everything about security today, tomorrow sustainability, and then combining together. Okay. Yeah, okay. So this one we will look in the afternoon, and this is a work basically done with one of the companies in UK. It's called British Telecom. Yeah, you might have heard. It's called BT Research. So I have a PhD student, like industrial PhD student. He has done this work. Yeah. Okay. Have a good lunch and see you at 2. Okay.